Hello, welcome back. So in our last lecture, we discussed the inheritance relationship. We also mentioned the override annotation, if you recall. Okay. And so basically that override provides one form of polymorphism. Polymorphism is also one of the couple important features for object-oriented programming. Okay. And then in this section, we will discuss more about polymorphism. Before we start that, I want to mention that Java is a strongly typed language. So what is strongly typed language? Okay, and maybe you already learned like Python. If you recall, for Python, Python is not a typed programming language because a variable doesn't need to have a type. The type is associated with the objects. Okay, but Java is different. Java is strongly typed programming language. So what that means is whenever you declare variable, you have the variable, then you must specify the type. Okay, and once the type is declared for the variable, and it must be remain the same. You cannot change it. Okay, so that's completely different from like a Python. Python, the variable can change. Okay, type you can initially associate with a string object. Later on, you can associate with a person object. Okay, so that's allowed in Python, but that's not allowed in Java because Java, when you declare the variable type um, is declared, and then you cannot change it. Okay, so like over here, animal. A. So A is a variable, okay, and the type is animal. And after that, you cannot change A like to object. If you want to do that, not allowed. Okay. And in this case, you not just declare, you also initiate, create an object and assign the object to variable A. So basically, if you recall, A is on stack memory, and this new animal will allocate a block of memory, and then A refer that memory on heap. Okay, but you are allowed to do this. Then you say, okay, new pet, and then you set that to A. This is allowed. Why? Because of the is a relationship. Because pet is an animal. Okay, so that's why this is allowed. Same thing, wildlife, you can new wildlife and then assign A to that is allowed. Because why? Because inheritance in relationship. So wildlife is an animal. So then that's allowed. So because of the inheritance relationship, basically it creates a subtyping relationship. Okay, so it says by definition, if class A inherits from class B, then the inheritance relationship between them indicates that A is B. Okay, just like what I explained previously. And this just means that A is a subtype of B. So all subclasses of B then are subtypes of B. Okay. Okay, then in Java, when we discuss about inheritance relationship and polymorphism, we have a concept called static type versus dynamic class. So what does that mean? Okay. So in this statement, A is a variable, the type is animal. So that's we declare is it. And this type, we call it a static type of the variable. And this static is a permanent set animal for the rest of the program. Okay. And static is also, so you can do new animal. Okay. So the type match with each other. So compiler will also allow this. So this is a legitimate statement. The type matches the variable type that you declared. Okay. And this new animal, if you recall, A, it's on stack, the variable. Okay, so it's, we also say it's a static type, is it? And when you do new animal, this it allocates a block of memory on heap. So some animal object. Okay. And basically this A will point to this animal object. And this object, we call it a dynamic class of the variable A. Okay. So this is the variable, the actual object at the end of the reference arrow points point to, is it? And it is a class to the right side, so we already see it. And it said if this dynamic class exactly matches or is subtype of the static type. So on heap, if this type is animal or is a subclass of animal, then the compiler will say, okay, it's legitimate. So the program will compile without any issue. But if the dynamic class is not the static type itself, or it's a subclass type, then the program will fail to compile. So keep this in mind, okay? So even though it at the compilation time, not running, normally when we say dynamic, we mean when the program runs, is it? But here, the compiler will check if the type match. So only the type itself and the subtypes are allowed. And so we saw, so on the right side of the assignment operator is that we have new, so that create the animal object on heap memory. And then you assign it to A, as is, we call that tagging it, okay, to the variable A. So this procedure, we call it dynamic binding, okay? And so dynamic binding, so it's at runtime, the object is created. Okay, so dynamic binding occurs at runtime. So that's why previously I mentioned that dynamic normally means at runtime. Okay, static is at compilation time. time. Okay. And the static type of an object that determines attributes and methods that's defined for that variables. And they are allowed to access. Okay, so if we do animal A equals new pet, then here keep in mind, okay, you are only allowed to access animals attributes and method, not specific to pets. Okay, like owner, get owner, they are not, so not accessible. But height, weight, those are accessible. Okay, accessible. So be careful, even though here you do the dynamic binding, is it? But still, the attributes and methods determined by the static type instead of the dynamic class. So keep this in mind. This is a very important point. Okay? Okay, because this section is about polymorphism. If you recall previously, I explained poly means many, and morphism means some forms. So many forms, is it? So how that many forms is achieved in inheritance relationship is through that dynamic dispatch. Previous dynamic binding, okay, be careful, that's different. Here we discuss dynamic dispatch. So what is that? Okay, so it says dynamic class itself. So it's bind at runtime, it's created at runtime, is it the dynamic, the objects, object created at runtime. And the dynamic class at runtime, it will determine which version of the method is executed. Okay, so because you see, A, the static type is animal. So animal has a toString method, has its own, so animal. Okay, animal also has a eat method, is it? And then our pet, we also define the toString method. We also define the eat method and through what? Through override annotation. Okay, and so when you do a.toString, so which toString is going to use? It's going to use A's or pets. Is it animals or pets? It's going to use pets. So this we call it dynamic polymorphism. Okay, dynamic dispatch. Okay. So it says the ambiguity around which version toString is wrong is called dynamic polymorphism. And dynamic polymorphism is resolved at runtime, not at the compilation time. Okay. And through the process of dynamic dispatch. And Java will automatically is to look for the furthest possible subclass in which the method is defined. So the furthest possible subclass. So in this case, it's from animal, and we inherit, we create subclass pet. Is it? So it will look furthest possible. So here you have toString, and here you have toString, so it will look furthest as a toString. Okay, so that's why here it will use paths toString. And because you see the two string, that animal has its two string, has its eat, and pets has it. So that's why we see in inheritance relationship, they provide the polymorphism. So two different forms of two string is it. So polymorphism is not just dynamic polymorphism. Dynamic polymorphism occurs at wrong time. Okay. So when the method get called, then it will look for the furthest possible subclass that's related to itself. There is another polymorphism, it's static polymorphism. Static polymorphism is occurred at compilation time. Okay. So dynamic polymorphism is through that override, override annotation. And also remember, the method override must have exact the return type, the header, and the parameter. All must be the exact same. Okay. Here about static polymorphism. So static polymorphism is through, we call it function overload. And one of the method is, we already saw it, if you recall, its constructor has, we learned two different forms of constructor. Is it so a default one? So it's without a parameter and in an explicit one. Value one. Is it? And those has a parameter, but they all share the same name. Okay. So method overloading means method can have the same name, but with different, so same name, but different signature. So signature means you can have different parameters. The function return type can also be different. Okay. And which one will be invoked if you recall the constructor? Is it the compiler statically? So at compile time, it will know which one. So it find the match using the parameter. So this is called static polymorphism. Hey, after we discuss the polymorphism, is it, so let's take a look at the summary using this picture about the polymorphism. Okay, so Java compiler, if you recall, we declare some variable as some dynamic class. Java compiler will check if some dynamic class is a subtype or is type of static type. Okay. And for the polymorphism, we said it can be achieved through compile at compile time or at runtime. Is it for the compile time? It's through method overloading. Okay, and the static type and the dynamic class, and it will also determine the static polymorphism at compilation time. Okay, through method overloading, and the other is at runtime. A runtime is through inheritance with method overloading, overriding, okay, with that at override annotation, and it is used in dynamic dispatch. So the case is the variable type may be the superclass, but you do the new create as a subclass, is it? So when you have method that's exist in superclass, also exists in subclass, you use override to you override it to implement the specific version for subclass. Then when the method get called, which specific is going to get called, invoked, as it's the subclass one is going to be invoked, not the superclass ones going to be invoked. So we call that dynamic dispatch. The dynamic dispatch then it resolves the dynamic polymorphism. So that's the idea. So just keep that in mind. So polymorphism has static related polymorphism and also a dynamic related polymorphism. So dynamic, so that this more regarding subclass and superclass. Okay, and that's just mean the method needed to match at compilation time for its method signature. They needed to match. Okay, and the last section in this chapter is discuss instance of. Previously, we already saw a couple of times, if you recall, and a new one called a get class method. Okay, so this is pretty useful for the equals method override. Equals method, when we do override, is supposed to be symmetrical. So what that means is if you have two objects to instance. If you do x that equals y, then y equals a should also be true. Okay. Otherwise, the same apply to both. Okay. So then, if you recall previously, when we override the equals method, because the equals method originally, the root is from object class. And so its parameter is type is object. So that's why when we implement, we always need to cast it to our own class. Basically, we now know our own class basically is a subclass of object. Is it? So then that involved the type casting. Is it? So type casting that allows us to create an aliens with a different static type. Okay, so that's the idea. So upcasting. So upcasting casting from subtype to supertype. Yeah, of course, that's always going to work because subtype a is a supertype. Is a relationship. Okay. So definitely that will always work. But downcasting. So can you cast an object to a person? Maybe or may not be. Is it? So that means you cast superclass to a subtype. Okay. So when we do this downcasting, sometimes it may cause some exception called the class cast exception. So exception we will discuss later, okay, in later chapter. So to prevent this kind of exception, generally speaking, we can do instance of check before we do downcasting. But we will see there is some issue when we use the instance of for our equals method check. That will not always correct. Okay. In our example, we will see. So there is another class that can better serve the purpose. So we call it a get class. So get class will check the true dynamic class. So here, be careful. True dynamic class. And keep that in mind. The dynamic class is discussed related with the static type. Static type is like you do animal A, then you do new pet. So this new pet part belongs to dynamic class, okay? And this A, that belongs to the static type. Static type, keep that in mind. Okay, so it says in equals method, we need to type a caset to a class if the input parameter has exact same dynamic class as the current object. Okay, then it says we can be sure that if the two classes have the same values for their member attributes and the same set of member attributes because they from the same dynamic class. Okay. So their object must be structurally equal. Okay. In this way, we can avoid the asymmetric behavior. We will see that in our example. So that's all of the concepts in this chapter. So in our next lecture, we will take a look at example to see how all of this concept that we discussed achieved in coding. So that's all for today, and we will continue our discussion in next lecture. Thank you. Oh, before we close this session, let's go back. I forgot one more thing. And yeah, if you recall, we have a short break and some photos about some national park with the big arches. Yeah, so that national park, the answer is Arches National Park. Okay. Okay, so we will continue our discussion in the next section. Bye.